Good afternoon, ladies and gentlemen. It's Art Ross speaking from SCP Science, talking to you about NovaWAVE and MiniWAVE manufactured by SCP Science. Today, what we would like to cover is we'd like to cover the use of the rack and the hardware and a software presentation, and then we can have a question and answer period at the end. You'll find a chat button in the top right-hand corner that you can type in your questions, and we'll answer them at the end of the presentation. So the NovaWAVE SA is a standalone microwave system that allows us to digest up to 12 samples simultaneously using 1 to 12 methods. We can run either quartz vessels or Teflon vessels in our rack to be able to do a digestion. So in front of me, we see that we have a rack, and the parts that are gray are Teflon coated with 12 safety pressure caps, where we can remove the safety pressure caps on top, take the samples over to the balance transfer rack so that you can take and you can weigh your samples into the tube at the balance. So we have little stands that allow us to place the vessel on the balance to be able to measure the quantity of sample. We have one for Teflon vessels and one for quartz vessels. If you're running quartz vessels, you can run them with all of the acids other than phlorboric acid and hydrofluoric acid. If you would like to run hydrofluoric acid, then we make vessels that are in Teflon. We injection mold the Teflon vessels here at SCP Science. The way that our safety pressure caps work and our vessels work is that we have a quartz vessel that's calibrated either to 45 or 50 mils, or there's ones available at 10, 25, and 50 mil, and this is a 75 mil vessel that's rated to 90 atmosphere. You place a cap on top, which seals on the side. There's a hole in the top. We use a plunger liner, which fits on top, and then we have a safety pressure cap that's serialized that you can tighten down, and when that's tightened down on top of the vessel, that then will release at 500 psi or 34 bar. We have vessels that are in quartz at 75 mil and Teflon vessels as well. The Teflon vessels fit into a quartz sleeve, so we're rated to 90 atmosphere, and the caps for the Teflon vessels are unique to our Teflon vessels, and you can mix and match the same vessels in a rack. So we have a 50 mil rack or a 75 mil rack, and you can put quartz and Teflon in the same rack to run at the same time. The way we accomplish this is that we have 12 independent magnetrons with 12 independent temperature sensors that measure the sample temperature for the feedback loop. So once your samples are weighed, acid is added, you take your samples over to the rack, you place them onto the rack, you ensure the caps are lined up with the venting channels. The safety pressure caps are placed on top of the system and closed. We use a torque wrench to tighten down the caps in all of the positions. Once they're all tightened down all the way around, then you can take and place it into the microwave. I have another rack here that's all ready to go. So one of the things I'd like to show you is that because we have 12 microwave cavities that are formed inside the cavity of the NovaWAVE, we have applicators. The applicators are what's providing the energy to the sample. So we automatically close this onto the rack so that we would form 6 mini microwave cavities on the front and the back to be able to do the digestion. So we can do 12. Each of the racks are numbered so that the system knows what's going in there, and we will show you how we can program quite quickly on the software. So I will take and I will place the rack into the microwave. The microwave has an automatic system so that once it gets pulled in, it then pulls the rack into position. It closes the doors, and then it starts the microwave digestion. So digestions are acid digestions using mineral acids, but we've also have developed a rack, and that's the rack that is Teflon coated in green here, which is used for extractions. So we can do extractions in the microwave. So the difference between a digestion and an extraction is that the digestion uses mineral acid. The extractions are using solvents to do extractions for the US EPA 3546 method, where you take 30 grams of sample, you add dichloromethane and acetone, or hexane and acetone, and we developed a rack that would allow us to heat up the sample when you have less than 20% of a polar substance in the rack. So typically an extraction is done at 110 degrees Celsius, 10 minutes at temperature and hold for 10 minutes. And we could use the same racks to do the extractions for NovaWAVE, for pesticides, herbicides, and total petroleum hydrocarbons. Once the rack is in the system, it will go through the heating profile, monitor what's happening. It then comes out the other side. So safety is important here as well. So the tunnel is made out of 13 gauge stainless steel, or 2.5 millimeters thick. It's triple Teflon coated. All of the other metal parts are Teflon coated. The doors are 1/2-inch aluminum. We have 8 interlocks to make sure that everything is closed properly before microwave energy is turned on. And we have explosion guards on either side. In the event of a rapid venting, there's the exhaust fan that moves 80 CFM from the tunnel through the exhaust into your lab exhaust system. So what we would like to do now is that we would like to call up the software, and we'll walk through the software on the digestions on the NovaWAVE. So we'll share the screen here and show you the software. So you can sign in either as an administrator or as an operator. We'll sign in under administrator. That way your chemists that run the system will have the capability of creating a method and editing a method. So we add the user's name, admin in our case. If you had it set up with a login, then you could use those. We'll log in. So the way that we program a digestion is that we do it what we call at the cycle level, where you can add a cycle and then you add a series of racks to those cycles. Each rack has an independent ID that is recognized as it goes into the tunnel so that we can select a method. So if I highlight cycle, I can create a method. Let's say that we're running an EPA method with HCl. We're going to run it in quartz. So I've now programmed all of these racks with exactly the same method. Let's say in rack 4, we have less than a full load, so we can turn off independent channels to be able to run less than a full load by selecting a vessel type. The reason why we would select a vessel type is that our infrared sensors that monitor the temperature in each one of the positions is based upon the energy coming off, and quartz vessels and Teflon vessels give off different IR energy, so that we need to track which one those are. So it's a simple program. If we're going to turn off those channels, then we've turned off those channels from 9 to 12. Let's say in rack 3 we have 2 kinds of digestions we want to do. We can go to the sample list. You can enter in a sample ID. You can enter in a mass or a volume. So we're using 0.5 grams, and you can add some remarks. So from the back side of my rack, from rack 7 till 12, I'm going to be running Teflon vessels. So I'm going to change the method because I'm going to do a complete digestion on some soil samples. So I'm going to add some HF, and I'm going to do that in Teflon and enter those values. So you can see now that I have quartz vessels and Teflon vessels in the same rack, and that is completely fine here to run those in that system. So once you have your cycles and everybody's programmed, you just need to say start digestion. It will start with the system. It checks to see where everything is at. So it will ask you to prompt the rack into the system. You push the rack into the system. It checks what the ID is. When it checks the ID of the rack, it says, okay, you're running program and you're placing rack 1 in there. You want me to run this particular method to run in quarts, and it will follow the temperature profile. So while this is going in, what we will do is that we will go look at the Methods tab. So on the Methods tab, we were looking at 3052 with HCl, so we can view it. So we can look at what this is. In that particular recipe, we're using 9 mils of nitric, 3 mils of hydrochloric, and there's our temperature profile to meet the requirements of the US EPA. 10 minutes to 180 and hold for 10 minutes. So on the digestion, so the digestion page comes up once the system or the rack has been in. It closes the doors, it engages the applicators, it checks the electronics, it starts all 12 magnetrons. The black number of 180 is the temperature we asked for in that particular method. The white numbers is the actual sample temperature inside the vessel. So you can see that we're coming up to temperature. Right now we're at somewhere in the 20s in temperature. The bar graph shows when it's in yellow that we're coming to temperature. As we get higher in temperature and we get closer to the set point temperature, and then when we reach the set point temperature, the yellow bar will turn to green, meaning that we're in the hold temperature, and then when it goes blue, it's all done. So that is how we would program and look at the digestions. Now you could go through and look at all of the methods that have been created or create new methods. Under utilities, under the users, what we have under the users, it allows you to apply passwords and assign who users are. So when they sign in, you have a log of who is actually running the system. We have a settings page. This allows you to set your date and time stamp for your jurisdiction of where you are. We store reports up to 100 days. The reports are about 16 kilobytes per report, and we'll get to the report shortly. We have an Ethernet connection that would send the reports. You could ask for the reports to be sent to a computer. We operate in English, French, and Spanish on the NovaWAVE currently. If you were to purchase a NovaWAVE SA or a NovaWAVE FA from SCP Science, you would get free software updates with the system. The system allows us to convert from a standalone to a fully automatic system. And when you have the fully automatic system, it's a system that allows you to run up to 14 racks at the same time. So here we're back to the digestion page. So under the reports page, it tells you which cycle is in process so that you would have a selection of all of the cycles that were run, and then by rack. And in this software, in the demo software, it doesn't store anything, but I have some graphs here that I would like to show to you from the reports page from actual digestions that we have done. So the main page that you get by rack is that it shows us all of the racks that were run, so that you would look at all of the racks. It gives you your sample ID, what your hold temperature was, and what the average variation of that hold temperature was, and which method was run. So if there was any problems on any one of the samples, it would indicate here that the sample didn't digest properly. So what does an individual report looks like? An individual report could look like this, where we've ran a sample that was at about 3 grams with 10 mils of nitric acid. This particular sample is high in sugar, high in fiber, and you can see that we had an exothermic reaction, which is shown here by this little bump that shows up here. So we followed our trajectory, and then when we got to 85 degrees, we had an exothermic reaction. So we actually pulled the energy off and let that subside, and then this is probably up the top end is an exothermic reaction due to the oil compound that was in that particular sample. In another digest for a soil, this is a typical soil digest that we would see, is that you would get a trajectory it would follow because there's no active materials in most soil samples, that it's pretty tame and pretty calm, and it goes all the way along. So you get one report for every channel that you're running. So we could come back here and we could look at our digestion that's going on here. So there we are, we're digesting to come up to temperature. So we saw the reports in terms of what reports look like. We saw the vessels that we have 75 mil vessels or 50 mil vessels for the NovaWAVE. They're available either in quartz or in Teflon. The nice thing about quartz is that you can see what you're cooking and how the digestion has progressed. We can mix quartz and Teflon in the same rack. You can have a 50 mil rack or a 75 mil rack. So very, very useful in terms of doing many kinds of digestions. Lots of accessories, balanced transfer rack. Once the rack is done, once the rack is done and comes out of the NovaWAVE, you would take it to the fume hood. And remember, you had a rack that has holes on the back, which would be away from you. Set it in your fume hood. Then we have a venting tool that actually lifts up the plunger on the inside of the rack so that you can vent it prior to opening the system, and the torque wrench allows you to open the vessel quite easily so that you can remove the safety pressure caps off of the top of it, take your vessels out and normalize in the vessel, put your plunger liners in a 50% nitric acid bath to wash. The caps come off and are washed as well, and the way you go to your ICP for analysis. So that's the end of the NovaWAVE presentation. I would like to do a presentation on the MiniWAVE at this time. So we're going to stop the software on the NovaWAVE, and we will go to the MiniWAVE. Remember, if you have any questions on NovaWAVE, if you were to type them into the chat, we will come at the end of our sequence here, or of our session, and we will have a question and answer period. So my assistant, Laura, will pull up the MiniWAVE camera, and you can see the MiniWAVE. So NovaWAVE is a 12-position, 12-magnetron system focused microwave. MiniWAVE is a 6-place rotating rack in a cavity with a single magnetron, so you would run one method for up to 6 vessels at the same time. The controller, sitting here in the center, allows us to be able to do up to 4 modules, so you could have 4 modules running 4 different methods, digesting 6 samples in each one independently. The information that I provided to you on the vessels are unique to MiniWAVE. They're 75 mil quartz rated to 90 atmosphere. We're using the same safety pressure cap. We're using similar PFA caps. We're using the plunger liner. The racks are black. They're Teflon coated. The purpose of the tube extender is to help modulate the temperature inside the tube. As you know, with free microwave, it keeps the microwave inside as microwave energy is reflected on metal samples. The torque wrench is used to tighten up the safety pressure caps on the tubes. We have the racks are numbered 1 through 6. Once you have all of your samples together, you pick up your rack, you place it into the MiniWAVE cavity, close the lid, connect the locking plate, then you can control the software from the module to run it. One of the other things that we've done and we've incorporated into MiniWave is that I have one showing you the front, so you get an independent number of the module, but on the back side of it we have the exhaust electrical connections, but we also have a air port for allowing dry air to go into the system so that you can rapidly cool your samples from 180 or 200 degrees. And typically it takes 3.5 minutes to cool 10 mils of acid from 180 degrees to 50 mils so that you could open up your vessels for normalized, or if you are running a 50 mil sample type from 200 degrees to 50 degrees C, it would take about 4.5 minutes to be able to run, to cool your sample down. So you can control time to temperature, time at temperature, set point temperature. We only work with 75 mil vessels in the MiniWave, either quartz vessels or Teflon vessels. The vessels need to be all of the same vessels in the MiniWave module. How would you select the difference between a MiniWave and a NovaWAVE? MiniWave is good for in-process QC, where you're running a few samples, want fast turnaround. You're a educational institution and you want to do teaching about microwave digestions. MiniWave is excellent for this. If you're doing high throughput, lots of samples, then NovaWAVE is the way to go. If you're running complicated samples, high reactive samples, NovaWAVE is the way to go. If you want to do extractions for environmental samples, NovaWAVE is the way to go. If you want to look at some extractions for flame retardants or amino acids, those kinds of things, at the research level, we have several people that are trying this with the MiniWave. Regular day-to-day samples, where you're looking at some in the morning, some in the afternoon, somewhere around 12 samples, MiniWave is perfect for that. If you're running more than 24 in a run, then NovaWAVE would be the selection that you would take. So I'm going to go over to the computer now, and we're going to share the screen on the MiniWAVE software. And a little bit of patience for MiniWAVE to come up with the entrance page here. So MiniWAVE and NovaWAVE are written in an open source software called Linux. And a few more seconds and we should have our opening screen here. There we go. So you can select a user level. Again, your chemist would select either administrator or operator. Again, we're pretty consistent in our passwords and all of those types of things here. So you can log in. So we will scan to see how many modules we have connected, and my software here today is going to say that I have 4 modules connected. So I can flip through each of the modules here to be able to program each one independently, so you can program one and do the other. So again, we select a method just like we did in NovaWAVE. So we would select a method. We'll do the HCl 3052. We're going to run this in a quartz vessel. We're running 6 vessels. You can put a sample ID in there if you would like. Once you have a sample ID, then you would enter sample ID, and away we would go, and we would start the digestion. So when we start the digestion, we make sure that the tubes need to be symmetrical. In the rack, we're running a rack of 6 tubes. So when we're doing MiniWAVE, we have an IR sensor that's taking the average temperature of the 6 samples, and that's what's being displayed in white. The black number again represents what your set point temperature is, and then you get a graph here in real time in terms of what's happening. So I can go from module 1 to module 2, And let's say that we're going to be running less than a full load this time. So we're going to run 3 vessels. This time we're going to be running Teflon vessels. So we will select a method that uses Teflon. Again, you can put a sample ID and I can start a digestion, and away I would go. So once this starts the digestion, I can scroll through the modules so that I get to module 1 and I can look at where our digestion is. Under the Methods tab, this is identical to what I had shown you with the NovaWAVE. So the method is very similar. You can edit, you can create, all of those kinds of methods. So we could look at the US EPA 3046. We could view this, and you can see that we're taking 15 minutes to come to 110 degrees and holding for 5 minutes. And we're using a 1-to-1 acetone mixture, and we're using 20 mils of it. So you could use this as your SOP. On the reports page, when you come to the reports page, you will select and it will, excuse me, will list which module we've run. So there you can see that we can also do multiple steps in terms of a digestion. So you have complete Windows capability to go from tab to tab to look at what's happening as you're running through your digestion. So we're providing you lots of information in terms of how things performed, so you have some traceability for what was done. On the reports page, you can save it to a USB. The controller has 5 USB ports so that you can output to that. On the diagnostics page, we have a operations page for service that can come in and look at things. And again, with utilities, you have settings and users just like you have in NovaWAVE. So we can come back to module 1, go to module 2, and see how our other digestion is doing. So just to recap on DigiPrep, excuse me, on mini-wave microwave digestion, it's an asymmetric system. It uses a rotating rack that does 6 samples. You can either run a Teflon rack or a quartz rack. They're 75 mil vessels. We have the option, if you have air attached to it, that you can have rapid cooling, and you can run up to 4 modules as things get expanded. Safety, again, we have dual interlocks. The cavities are triple Teflon coated. There's an exhaust fan that runs to, if there's any venting, and while it's cooling to exhaust, we're exchanging the air inside the cavity about 100 times per minute. And that sort of wraps up all of what we have here on MiniWave. So this would be a very good time to be able to answer any questions. So Laura will look at the questions there. So if you would like more information, your sales rep had sent you a link to it. You can contact them, or you can contact us at sales@scpscience.com. Well, if we have no questions from the field, on behalf of SCP Science and the employees here, we have 160 employees in a 74,000 square foot building that we manufacture the microwave systems. We have a Teflon coating line, scientific glass shop that makes the vessels. We have a QC department that QCs them at 90 atmosphere. We are very proud of what we're selling, and we appreciate you taking time from your busy day to listen to me, Art Ross, the product manager for microwave digestion systems here at SCP Science. We thank you very much for taking the time, and enjoy the rest of your day. Bye now.